We left off talking about consumer preferences and the budget constraint. Remember that we captured consumer preferences through a utility function and also through what's known as an indifference curve. And all an indifference curve does is it reflects consumer preferences without regard to what they can pay. It shows you that if they didn't have to worry about money, what kind of goods would, bundles of goods would a consumer consume? The budget line was important because it actually showed what the consumer can afford to pay, but it doesn't have any regard with respect to preferences. So we've got two pieces of a puzzle here that are very important. One that reflects preferences, those are indifference curves, but doesn't reflect what's affordable, and the other reflects what's affordable, that's the budget line, but doesn't reflect preferences. We're going to combine the two to determine how the consumer will actually behave. What's important here is that the consumer will choose the consumption bundle that gives them the highest possible level of utility, that is, the highest possible indifference curve. To illustrate this, let's go back to our pizza and beer example. What I've drawn is an indifference curve space with quantity of pizza consumed on the x-axis and quantity of beer consumed on the y-axis, and the green line represents the budget constraint. One possible indifference curve that a consumer might choose to consume along might be this one. This curve shows the different combinations of pizza and beer that would give the same level of utility. The issue is that that indifference curve is such that none of the bundles along the indifference curve are affordable. I know that because that indifference curve isn't touching the budget constraint. You might actually think about moving that indifference curve a bit closer to the origin to try to see if you can find the set of goods that the consumer might afford and they would also prefer. That's illustrated with this indifference curve. But again, the different bundles along that indifference curve aren't feasible because you can't afford to consume any one of them given the amount of money that you have and the prices that you face. If we further shifted that indifference curve in, you might move to a place like this. What's interesting here is that there's two spots where the indifference curve crosses the budget line, here and here. In both instances, the consumer could afford to consume at the point closer to the beer axis or at the point closer to the pizza axis. But they can actually do better than that because if you shifted that indifference curve out a ways from the origin, you could actually still maintain feasibility in that the indifference curve touches the budget line, but that you've shifted that utility, the indifference curve out as far as possible. Such an indifference curve might appear as this. And that's actually the indifference curve that the consumer would want to choose or consume along. It shows or it reflects the preferences for beer and pizza, but it's also just tangent to the budget constraint. So we know that at the point where the indifference curve is touching the budget constraint, or the budget line if you want to call it that, the consumer can afford to consume. And so that point is here, where there's, let's say, 3 units of pizza and 4 units of beer. Now, this might look familiar to you because it's essentially the cost minimizing example that we saw with production, but in the context of choosing to consume different units of goods in your own consumption bundle. Now, what's also important here is that the slope of the budget constraint, or that budget line, is equal to the slope of the indifference curve. It's the exact same kind of concept as we had when we were trying to choose the least cost bundle of inputs in a production example. Now, that indifference curve is actually quite cumbersome to use, and what we'd like to be able to do is come up with a way to illustrate the relationship between demand for a good, and in fact what's in the consumer's consumption bundle, and the prices that they face and the income that they have. Now, remember that those consumption choices depend on the budget line, which in turn depends on prices and income. And so if there's a change in a price or a change in income, that's actually going to affect the position of the budget line, and that's going to then influence the consumer's utility maximizing consumption bundle. The changes in those goods prices are actually very useful because it allows us to map out what's known as a demand curve. And this just simply shows how much would be demanded at different prices for that good. It's also convenient because it means that we don't have to use an indifference curve and a budget line to try to figure out what happens to consumption when prices go up or down, or when income goes up or goes down. We're going to illustrate that using the beer and the pizza example as before. So on the left-hand side of the screen, I've got the indifference curve diagram, and then on the right-hand side, I've got a new diagram. And in this new diagram, we're going to draw a demand curve. I've got quantity of pizza labeled on the x-axis and price of pizza labeled on the y-axis. And at the initial prices that I faced, and with U star units of utility, I know that the consumer would choose 3 units of pizza and 4 units of beer. Now remember that the initial price of pizza was $4 a slice. So what the diagram on the left is telling me is that when the consumer faces a price of $4, they would choose to consume 3 units of pizza. That tells me 1 point on the consumer's demand curve. What I'd like to know is how a change in the price might give me a different point on that demand curve. And so let's just say, for the sake of argument, that the price of pizza increases to $5. When that happens, we know that that's going to change the position of the budget line. In particular, if the consumer only consumed pizza and the price increased to $5, and since they have $20 available to spend, we know that the consumer would then buy 4 units of pizza. If we redraw the budget line to reflect that new intercept on the pizza axis, it would look something like this. It's now a steeper line, and that simply reflects the fact that the price of pizza has gone up. What I would do is then try to find the new utility maximizing level of beer and pizza, subject to the fact that they have to consume somewhere along that budget line. We can suppose that it's represented with this green indifference curve and the different level of utility U star star. Now, one thing that's important here is that as soon as that utility or that indifference curve is shifted into the intercept, you know that utility's gone down. Now, at the new point of tangency between the budget line and the new indifference curve, we can actually figure out what would be economically optimal for the consumer to do. In this case, they would choose 2 units of pizza and 5 units of beer. The 2 units of pizza when the consumer faces a price of $5 gives me another point on the demand curve over in the diagram on the right. What it says is that if the price of pizza were $5, that the consumer would then choose to consume 2 units of pizza. And that's another point on the demand curve. I could go through different combinations of different prices for pizza, mapping out these different points, and then if I connected all of those dots, I would get this downward sloping line, and that simply is the consumer's demand curve for pizza. It says, holding all other things constant, how much pizza would be demanded as the price of pizza varies. To say this a different way, the demand curve is a graph that indicates the amount of a good that a consumer is willing to purchase at alternative prices. We can also represent this through what's known as a demand schedule, and that's just a table containing the optimal price-quantity combinations demanded in different combinations by a consumer. What's important here is that we're invoking the ceteris paribus assumption, that is, all other things are being held constant. In the derivation of the demand curve on the previous slide, we were actually holding fixed the amount of income that the consumer had and the price of beer. All we're doing is isolating the relationship between the price of pizza and the quantity of pizza. Now, there's a couple things that are important when it comes to these demand curves. One of them is what happens when income changes. We talked about how income changes affects the position of the budget line, and what you should see by now is that if the budget line changes because of an income change, that's going to change the optimal combination of goods that the consumer will choose to consume. That also means that it's going to affect the position of the demand curve for the good in price quantity space. In particular, in this context, a change in income will cause a parallel shift in the budget line. For example, let's assume that the budget or income that the individual has in the pizza beer example was increased from $20 to $40. What would be the effect of the demand for these 2 goods? We can illustrate what would happen with the doubling of income using the original indifference curve diagram. So here I've drawn the original budget constraint or budget line, as well as an indifference curve with utility U star. And we know that the optimal point of consumption is going to be indicated with this black dot. What happens when income goes up is that the budget line will shift out, let's say towards this second green line. When that happens, the consumer can actually adjust their consumption bundle and consume more units of both beer and pizza. They do that by trying to figure out the optimal combination of pizza and beer that reflects the fact that they want to maximize the amount of utility that they receive by consuming pizza and beer, given the prices and income that they have. And so if we did that, what we would find is a new point of tangency between the new budget line and a new indifference curve U star star. That's indicated by the second black dot. The consumer is now better off because they have a higher level of utility. We know they've got a higher level of utility because they're on an indifference curve that's moved further away from the origin, and they've also increased consumption of both pizza and beer. That's very useful, but what it doesn't help us understand better is how the demand curve might change when income changes. But to get at that, we need to understand something about the nature of the goods that we're dealing with as income changes. In particular, we need to understand whether the goods are what we would call an income normal, or a normal good, or an income inferior good. A normal good is a good that you consume more of when your income rises. Conversely, a normal good is a good that you consume less of when your income falls. An inferior good is a good that you consume less of when your income rises, and again, conversely, an inferior good is a good that you consume more of when your income rises. Note also that a good can change from being a normal to an inferior good depending on the extent of the income changes and how much income you have to begin with. Let's illustrate this with two different types of diagrams. They're both demand curves, but they're demand curves for different goods. The demand curve on the right is for an inferior good. An example of an inferior good might be Kraft Dinner. The demand curve on the left is for a normal good, and an example of a normal good might be fruits and vegetables. And indeed, the empirical evidence that is available suggests that as income increases, so too does demand for fruit and vegetables. So in this particular case, where we're assuming fruits and vegetables are a normal good, if my income rose, what that would do is that would shift my demand curve for fruits and vegetables up from D to D prime. If I were dealing with an inferior good, and a good example of an inferior good might be Kraft Dinner, what happens here is that as my income goes up, I actually have more money that I could allocate to other goods that give me more utility, maybe a gourmet version of macaroni and cheese. And when that happens, my demand curve for that inferior good shifts down, in this case from D to D prime. What's important here is that when income goes up, demand for a normal good increases. That's illustrated here on the left. And when income goes up, demand for an inferior good falls, and that's illustrated here on the right. The relationship between quantity demanded and income is actually very important in economics, so much so that we have a special name for it. In particular, we call that relationship an Engel curve. And this is just a curve showing, for fixed level of prices, the relationship between income and the quantity of a good consumed. The Engel curve will slope upward if the good is a normal good, but it will slope downward if the good is an inferior good. It's also important to recognize that those Engel curves could be upward sloping over some region and downward sloping over other regions. Now, it's named after a very important economist, Frederick Engel, who examined the relationship between consumer income and the proportion of income spent on food, ceteris paribus. What I want to emphasize here is that we're holding constant prices and we're only looking at the relationship between quantity demanded and income. We can illustrate this graphically with the following. You'll notice on this diagram I've got income plotted on the x-axis and quantity demanded plotted on the y-axis. This downward sloping red line is an Engel curve for an inferior good. What it shows is that as my income goes up, the quantity demanded of the good falls. An upward sloping Engel curve, like this green curve, is what an Engel curve for a normal good would look like. As income goes up, quantity demanded of the good also goes up. We can also have a combination of these types of goods. So for instance, this blue line, where it is initially rising, reaches a peak, and then falls, shows regions where a good is a normal good and regions where it's an inferior good. In those regions where the Engel curve is upward sloping, that's where the good is a normal good. In regions where the Engel curve is downward sloping, that's where the good is an inferior good. This is a good place to stop, and we'll pick up the discussion about Engel curves and the relationship between quantity demanded and income in class.